So today we're going to be looking at locating images in lenses. Locating images in lenses, you're going to find is going to be very, very similar to locating images in mirrors. The biggest difference is going to be that rather than looking at light reflecting back like you did in a mirror, we're going to be looking at light refracting through the lens or passing right through. So a couple of different terms that you'll need to know throughout this note. First one is a converging lens. So remember we had a converging mirror that took light, reflected light, and it bent it towards the normal. It's going to be the same idea with a converging lens. A converging lens is going to have the thickest part in the middle. It's going to cause a parallel incident ray to converge through the focal point of the lens. So again, we're going to have converging light. We're going to have a parallel light ray coming in, and a converging lens is going to cause that light to bend towards the normal. It's going to cause that light to bend towards that converging lens right in here. On the other hand, we have our diverging lens, just like we had a diverging mirror. A diverging lens is thinnest in the middle. What a diverging lens is going to do is it's going to cause an incident parallel ray to spread apart or diverge. So it's going to spread light apart. So again, you're going to have a parallel ray coming in, but rather than having that parallel ray go towards the normal, we're having it diverge away from the normal. This light here is getting scattered. As you can see, the apparent light source is still going to go through the focus. So we're still lining up through the focus, just this time the focus is going to be on this side of the diverging lens rather than on this side of the diverging lens. We're actually going to be taking a shortcut when we draw these lens diagrams. So we know that light is refracted or light is bent every time that it changes medium. So when we take a look at a lens, we're going to have light coming in. Our first medium here is going to be air. Our second medium is going to be glass. So light is going to go through the air. It's going to hit the glass. As soon as light hits the glass, it's going to slow down. It's going to bend. When light exits the glass, it's going back through air again. So light is actually going to bend a third time. So we see the bending of light 3 times. It bends first through the air, then it bends through the glass, then it bends through the air again. What we're going to do is we're actually going to take a shortcut. We're going to draw a dotted line through the middle of the lens, and we're just going to show it bending twice. It really bends 3 times, but it's just going to make our diagram so much easier. So our shortcut is going to look like this. We're still going to be measuring the same angles. So that angle of refraction, that angle that light is coming out on this side, it's still going to be the exact same, but rather than having 3 types of bending, we're only going to have the 2 right along the center line of the lens. A little bit more about terminology for our converging lens. We've got this idea of our optical center. So the optical center is the exact center part of the lens. We label that as O. We also have something called the principal axis. This is the same principal axis that you saw in mirrors. It's just a line through the middle of the optical center, and it's perpendicular to the optical center. So this is going to be a nice gauge for us to see if light is coming in and if it's parallel. We also have something called the principal focus. Just like we had a focal point on a mirror, our principal focus is actually going to be on this side rather than on this side. In mirrors, the focus was on this side because light was traveling to the mirror and it was bouncing back. Now we have light is being refracted. Light is traveling through the lens. So light is going to travel. It's going to hit the lens. It's going to travel through the lens and through the focal point. So this time we want to have our focal point after the lens because this is where the light's going to converge through. We also have something that's called, actually I'm going to go back up here. We also have something that's called 2F. That 2F is just 2 focal points away from the lens. It's the exact same as what C meant in a mirror. Lost my train of thought. It's exactly what C meant in a mirror. So just like C was double F, here we do have double F, but there's no center of curvature this time. So instead of calling it C, we actually just call it 2F. With lenses, we actually now have 2 different sides. So with mirrors, light could only strike on one side. It would strike on the reflected surface and it would bounce back. The back of the mirror was actually painted black, so no light was reflected off of it. Here with lenses, it's clear glass, so light can actually travel through this way, and light can actually travel through this way. That means there's going to be two focal points. There's going to be a focal point on this side, like we saw before, for light traveling in this direction. And for light traveling in this direction, we're going to need a second focal point. That second focal point is here. That means we're going to have a second 2F. Notice that we just marked it with a little dash so we can tell the difference between our primary focal point. I usually just call this F prime. So this is just here to represent the light that's going to be coming in on this side of the lens. So our secondary principal focus is the focus that is on the same side of the lens as the incident rays. So I'm always going to draw my incident ray on this side, incoming light on this side. It's going to pass through my lens on this side. My secondary principal focus, my F prime, is just here as a marker, and it's here for any light coming in on this side. Even though light does come in on this side, I'm not going to draw any incident rays on this side. It's going to make my diagram look confusing. So I'm only going to draw incident rays on one side so we can actually see where the image is going to be located. Last thing we want to talk about is that idea of the principal focus. The principal focus, and this is for diverging lenses. So a diverging lens does have a principal focus, but for diverging lens, my principal focus, if you can see, is actually switched to this side. So rather than having my principal focus, my F on this side, like I do for converging lenses, a diverging lens, I actually have my F on this side. Remember, that's because a diverging lens is going to scatter light. So as light comes in, it's going to be scattered in this direction, but it's going to be scattered so the apparent light sources are still going through F, my principal focus. So if we take a look between this diagram and this diagram, they look the exact same, but all that's happened is I've actually just switched my F's. So in a converging lens, I have my F prime, my secondary focus on this side, and my principal focus on this side. In a diverging lens, I have my principal focus on this side and my secondary focus on this side, just depending on how light's going to be scattered. So the diverging lens, again, has a secondary principal focus, but the secondary principal focus has been swapped. It's now on this side of the lens. All right, let's go ahead and let's look at locating images in a lens. So just like locating mirrors in a lens, we're going to use a couple different rules that are going to allow us to locate an image in a lens. So a couple terms that I want to talk about first. I want to talk about the term emergent ray. We haven't had one of these yet. We've had an incident ray and we've had a reflected ray. Now we have an emergent ray, and this is the light that's going to leave the lens after refraction. So we haven't seen actually refraction yet. We just know what it is. So the light is going to pass through the lens. It's going to come out the lens this time. So the light that comes out the lens, that's going to be called the emergent ray. The thicker the lens, the more displacement that's going to be caused. So the thicker the lens, the more the emergent ray is going to bend. That's because it spends more time in glass. It slows down longer. The thinner the lens, the less the emergent ray is going to bend. It spends less time in glass, so it's going to bend less. We're going to have 3 rules for finding images in converging lenses. You're going to find that those rules are almost the exact same as our mirror rules. So we're actually going to start with the same rule that we started with last time, and that's going to be a light ray that's coming in parallel. So any ray that comes in parallel to the principal axis is going to be refracted. It's going to pass through the lens, it's going to bend, and it's going to be refracted through F, the principal focus. So remember, in a mirror, we went in parallel, we came out through this F on this side. Now we're going in parallel and we're coming out through F on this side. So same rule, is just going through the lens rather than being reflected back. Now let's take a look at our second rule. And our second rule is going to say a ray that goes in through the secondary principal focus, or F prime, is going to be refracted parallel. So again, same rule as the mirror, and this is again really opposite from the first rule. So now we're going to go in through F. We've got an F on this side as well too. We're going in through F prime, and we're going to come out parallel on this side here. And our last rule is going to be similar to our center of curvature rule, but this time we don't have a center of curvature, so we're going to use the optical center. So this time we're going to have a ray that's passing through the optical center. A ray that's passing through the optical center is going to go straight through without being refracted. So if we happen to have a ray that lines up exactly with the optical center, it's going to go straight through the lens. It is not going to be refracted. Now we're going to take a look, and we need to look at diverging. So this should say diverging here. Notice that it's a diverging lens. And our rules for diverging are going to be very, very, very similar. But again, we're going to be dealing with apparent light sources. So for diverging lens, a ray parallel to the principal axis, so parallel to the principal axis, is going to come out through F. So again, it's going to scatter away from that principal axis. How do we know it's going through F? Well, it's lined up with F on this side because in a diverging lens, F is on the same side. It's on the same side as the emergent rays. Now notice that this is a nice dotted line here as well too. This is a dotted line because again, this is an apparent light source. The light isn't actually coming from here. It just looks like it's coming through here. Anything that's solid represents an actual light ray. So the light ray comes in parallel, it's refracted through F, and it goes through and it scatters and it's refracted up in this direction. Rule number 2 is going to be if I'm going in through F. So this one's a little bit trickier to see, but if you actually think about this, or if you pause the video and you go get a ruler and you line a ruler up, you're going to see that this straight line here is a straight line, but it's a straight line that appears like it's going in through F. So this light ray, if there wasn't a lens here, would actually end up passing through F. However, as soon as it hits the lens, it's going to be refracted and it's going to come refracted out parallel. So I'm going in through F and I come out parallel. This is very similar to the virtual image that we produced in a diverging mirror. My last rule is the same as rule number 3. So whether or not you're dealing with a converging or a diverging lens, they're the exact same. And here I just have my rule of going straight through my optical center. So a light ray that's traveling straight through my optical center of my diverging ray is again going to continue straight on through my optical center. Now we know our rules, so I've actually given you a little bit of homework, and your homework is going to be to try these ray diagrams on your own. There's no assignment for this week, so I'm actually going to post a second video that shows me taking them up. So there's an assignment at the bottom here. I want you to go ahead, I want you to open that assignment, I want you to use Google Draw just like you did last time to try to figure out those ray diagrams for lenses, and then I'm going to actually show you the ray diagrams for the lenses and where you would expect to find your image. Remember that I want you to state SALT as well too. So you want to make sure that you're describing the size, the attitude, the location, and the type of the image. Good luck, and once you've tried the assignment and you have your answers, go ahead and watch the video and you can check and see if you're right.